The Sun's activity is intensifying as solar cycle 25 reaches its peak, increasing the threat of solar superstorms that could disrupt our technology-dependent lives. This video delves into the latest research on these powerful solar phenomena, exploring their significance and the strategic measures we take to protect our technological infrastructure. Join us as we navigate the complexities of solar activity and learn how we can shield our society from the potential havoc wrought by the tempests of our nearest star. Solar superstorms, including solar flares and coronal mass ejections, CMEs, are some of the most potent natural phenomena our planet faces. Solar flares are intense bursts of radiation caused by magnetic energy released from sunspots, visible as bright areas on the Sun. Their impact ranges from minor satellite communication disruptions to radiation storms endangering astronauts and satellites. Coronal mass ejections are giant clouds of solar plasma and magnetic field lines that can trigger intense magnetic storms on Earth, disrupting power grids and communication networks. The Carrington event of 1859, the strongest geomagnetic storm on record, serves as a stark reminder of the Sun's potential impact. It disrupted telegraph lines, highlighting the need for preparedness. A major solar storm in 1989 knocked out power across Quebec, showcasing the potential consequences. With the Sun's activity predicted to peak, the risk of another extreme solar event grows. Historical data suggests these solar maxima periods can unleash chaotic weather on Earth. Recent analyses of tree rings and ice cores have helped identify past solar superstorms, further emphasizing their potential future impacts. Global eyes on the solar threat. Technological advancements and a deeper understanding of solar physics have spurred the development of a sophisticated network of observatories and satellites focused on the Sun. NASA's Solar Dynamics Observatory, SDO, and the Parker Solar Probe provide continuous, detailed observations, essential for understanding solar activity's complexities and forecasting significant events. The European Space Agency's Solar Orbiter complements these efforts by capturing high-resolution images of the Sun's poles, a previously underexplored area, offering fresh insights into the Sun's magnetic activity. Revolutionizing predictions with new technology. Forecasting methods have seen transformative improvements recently. The NOAA Space Weather Prediction Center, for example, has updated its forecasts for the current solar cycle, anticipating quicker and more intense peaks in solar activity. This enhanced predictive capability results from both improved observational data and advanced computational models that more accurately simulate the Sun's surface and magnetic field changes. Integrating artificial intelligence in solar monitoring. The incorporation of AI and machine learning techniques is revolutionizing how we monitor and predict solar activity. These technologies analyze vast amounts of solar data more quickly and accurately than ever before, identifying patterns that may precede significant solar events. This proactive approach allows for more precise and timely warnings, potentially saving billions in damage and preventing widespread technological disruption. Collaborative international efforts for a unified response. The international space weather community has been actively collaborating to enhance global response capabilities to solar threats. Organizations like the International Space Weather Initiative bring together experts from around the world to share data, research, and strategies. This global network ensures a unified response to solar phenomena, maximizing our collective ability to manage and mitigate the effects of solar storms. Public and private sector partnerships. Increasingly, governments are partnering with private sector technology firms to develop new tools for space weather prediction and monitoring. These partnerships aim to leverage private innovation and agility to supplement traditional governmental capabilities, enhancing the overall resilience of our technological infrastructure to solar event. Fortifying our defenses against the solar fury. As the likelihood of encountering severe solar storms increases, the importance of strengthening our technological infrastructure cannot be overstated. Efforts are underway globally to enhance the resilience of power grids through the implementation of more robust transformers and the installation of systems designed to automatically stabilize voltage and manage sudden power surges. Similarly, satellite designs are increasingly incorporating hardened electronics and radiation shields to protect against solar-induced anomalies. International cooperation, a necessity, not an option. The global nature of solar impacts calls for international collaboration. Programs like the International Space Weather Initiative have brought together experts from around the world to share data, tools, and strategies for dealing with solar phenomena. This cooperative approach not only helps in standardizing response procedures, but also in pooling resources for the development of better predictive tools and mitigation technologies. Educating and preparing the public. Alongside technological advancements and strategic partnerships, increasing public awareness about solar weather and its potential impacts plays a critical role in societal resilience. Educational programs, early warning systems, and community preparedness plans are crucial in minimizing the disruption caused by solar storms. By informing and preparing individuals and organizations about how to respond during significant solar events, societies can mitigate the adverse effects of these celestial challenges. Enhancing cybersecurity measures. With the increasing reliance on digital networks, cybersecurity becomes a vital component of our defense against solar storms. Solar events can trigger geomagnetic disturbances that may disrupt communication networks and data storage facilities. Strengthening cybersecurity protocols to handle sudden losses of connectivity and data integrity is essential for maintaining the functionality of critical infrastructure systems. As we deepen our understanding of solar activity, the critical need for global preparedness against solar superstorms becomes evident. These powerful cosmic events, magnified by the sun's peak activity in its 11-year cycle, threaten to disrupt our infrastructure, from power grids to communication systems. Investments in robust electrical grids, advanced satellite protection, and resilient communication systems are essential to mitigate potential damages. Furthermore, international cooperation in space weather forecasting is crucial, allowing for a synchronized global response to imminent solar threats. Public awareness and education about the risks of solar weather and its impacts are equally important. Thank you for joining us on this journey through the cosmos. If you enjoyed this deep dive into the cosmos, don't forget to like, subscribe, and click the bell icon so you won't miss out on our future space adventures.